Good evening from Dublin, Ireland, and welcome to the third Internet Reunion Club public session sponsored by Internet 2. Our thanks to Anna Hunsinger, Vice President of Community Engagement in Internet 2, and to Kelly Farrell, Manager Community Events, who's guiding us through today's session. My name is Dennis Jennings. I was the first program director for networking at the National Science Foundation in 1985-86, and I had responsibility for the initial design and implementation of the NSFNet. And I'm moderator of this session on using the internet in the years 1983 to 1992. The session will focus on the use of the internet as opposed to the technology and building on the internet in that period. That is before the web, before the browser. And for many people, there was no internet until the web and the browser. And what we want to demonstrate is, yes, indeed, there was, and a lot of usage of that internet. This session will follow the usual format with a panel of speakers who were internet leaders back in those early days, and will each give us a short 10-minute talk. And then after the talks, there'll be an opportunity to ask the panel some questions. Please use the Q&A button on your Zoom page if you want to ask a question. Our speakers today are Ed Kroll, the author of the Whole Internet User's Guide and Catalog, and he'll speak on tools and services on the internet. Followed by Milo Medin and Tom Stone. Milo, formerly of the global NASA, beg your pardon, not NSA, NASA, National Aeronautics and Space Administration Science Internet at NASA Ames, and Tom was, I believe, the Antarctic project leader. And they'll speak on space research and NASA. Followed by Yvonne Marie Andres, who is the CEO and co-founder of Global SchoolNet and FredMail Network, who'll speak on education on the internet. And lastly, Larry Smarr, former director of the NCSA, the National Center for Supercomputer Applications, one of the NSF's supercomputer centers starting in 1985-86, who'll speak on supercomputing from the desktop workstation. So first of all, we have Ed Kroll, an Internet Hall of Fame inductee in 2017, the original networking manager for the NCSA, the National Center for Supercomputer Applications at the University of Illinois, which was an early adopter of the IP protocols. Ed managed the establishment of the NSFNet prototype and the regional networks. And to help people connect, he wrote The Hitchhiker's Guide to the Internet in 1987, one of the earliest non-technical internet guides. He followed this with the Whole Internet book series, selling over 1 million copies and translated into over a dozen languages. Ed, the floor is yours.
Thank you. Well, I started thinking about how this all happened, and it sort of had a bunch of technologies which were sort of idling, which all sort of hit go at the same time. And so we went from virtually nothing spectacular to something spectacular in the space of about 5 years. So let me try to share something here. Oh. Shit. I can't get to the top of my screen to start running my show. There we go. Okay, so just a little bit of level setting here. When the internet first started, it was pretty much the big kind of communication people had was a 56 kilobit line. The telcos had these 1.5 megabit trunks, but they couldn't sell them to you because they were regulated. And the only thing they could sell you usually was a voice channel, a 56 kilobit line. If you wanted to, and whether or not they could sell it to you depended on what, if you were within the same state, they had one set of regulations. And if they were in across state lines, they had another set of regulations. And so things were hard to do at high speeds, but it didn't matter because if you were at home, the best you could do was 30 bits per 300 bits per second or 1200 bits per second. And the terminals you had were a teletype, which was World War II technology, a glass teletype, which was the same thing, but rather than having a printer, you had a CRT, and it could go 9600 bits per second, but you couldn't do that at home anyway. If you wanted graphics, there were this thing called a Tektronix made a graphics terminal down here in the bottom right, which is really interesting because it had a screen which was write-only memory, and as you drew a line on it, the phosphor would continue to glow. It was sort of like an Etch-a-Sketch where it stayed glowing until you hit the erase button, and then the whole screen would go bloop, and it would be dark again. Anyway, so that's what you had to work with at that time. And the internet was started in the 70s as ARPANET, and the three big applications for it were remote login, so you can log into somebody's computer across the internet, you can transfer files, or you can email, and life was good. Unfortunately, you couldn't share things very easily because you had to be able to log in to do any one of these things. So things changed a bit when all of a sudden this thing called anonymous FTP, or not anonymous, is a sign-on which anybody could use for these two applications. So if you wanted your buddy to say, look at the program I wrote, you could tell him just put it in a particular directory and say, anonymous log telnet to me, and you can use and run the program. Or you could say, if you wanted the program, you would do a file transfer and say, I want to log in as anonymous, and they'd have a special directory which people could download files from. An email was email, but it was text only. Now, there were a few things which were happening outside of the internet per se at this time. One was you had a set of email networks. BitNet and CSNet were two of them in the educational arena, and they were sort of a little different than email on the internet because they were sort of daisy chain networks where if you wanted to send a message to somebody in Cornell from Illinois, once a day your computer might dial up Purdue, and then Purdue might twice a day dial up somewhere else, and eventually it would get to there. So it was a slow store and forward kind of operation. The other thing you had over here was there was the starting of bulletin boards, which were dial-in chat rooms, sometimes on a particular topic, and that sort of technology sort of morphed into the AOLs of the world. But they were essentially just dial in and use their particular protocols to do things. Then from BitNet, because it was basically an email network, you started to get things called listservs, which were a combination of mailing lists. So you could send a message to a listserv and it would send it to all the subscribers, but it also allowed the capability of requesting files. So you'd email something and say, send me the conference directory, and it would send you an email back which had the conference directory for a particular conference. But the interesting thing to notice in all of this is the way you found out about things was out of band. It was word of mouth. In a conference, someone would say, there's this really neat thing at Cornell for anonymous FTP. And what we got in all of this was Star Trek on a teletype. You could, we used to do this at Illinois. We had a tip, which was a dial-in node to the ARPANET, and over lunch, we would connect up to someplace like Slack or Stanford Linear Accelerator Lab, and on their computer, they had a Star Trek game, which you would type in numbers like number 3 was a short-range sensor scan, which was this thing here, and there were commands for firing the torpedoes, and you might get damaged. And the interesting thing about this is, well, you can still find the game. There's the URL for it, and you could get the source, and it's 42 kilobytes of source. So you can keep thousands of copies on your phone. But in the middle of the 80s, you had a bunch of technologies which were coming about. You had graphics workstations take form, but they were really expensive, like a Sun 2, which would do really good graphics, and a PC kind of processor was $50,000. In 81, you had MS-DOS coming out, but all you got was remote login for that. In 85, you finally started getting first graphics but no internet functionality. Windows didn't believe in the internet. They were going to do their own. So if you wanted to use the internet at that time, you had to strap on some kind of protocol stack, which would allow you to get out to the internet. And it wasn't until 95, which is when the Microsoft finally bit the bullet and decided the internet was good. Macintosh was not much better, but Macintosh users were hardier because they were not mainstream, expect everything of themselves. At the same time, you had a modem come out, which would test the phone lines and push them as fast as they could possibly go with the technology. And so people at home could get speeds up to about 9,600 bits per second, which was reasonably acceptable to do low-end graphics. And then in 86, you had NSFNet for 56 kilobits going to universities. And 88, you had 1.5 megabits and Ethernet to researchers' desktops. So in fact, if you look at this in sort of the 85 to 88 range, there's everything you needed to do graphics processing on the over the net. And this is the complicated thing that happened. Now you had, so you had all these disparate anonymous FTP servers and no way to discover things. Out of the library community, a fellow by the name of Brewster Kahle decided to take this full text searching protocol that librarians have been developing for years and created a thing called WACE, which would take whatever files it could find and do a full text index of them and make them searchable. At the same time, a guy up at McGill University in California, Canada, Alan Emtage, decided he could build this thing which would take all of the anonymous FTP servers that were known and crawl around in all of them and do a directory, which was all of the anonymous FTP servers. And so suddenly you didn't need to do word of mouth. You could find things you wanted. At University of Minnesota, they developed a thing called Gopher, which was a nice user interface, but character oriented again, to do anonymous FTP kinds of things. So suddenly you didn't have to be a techie to download a file. You just looked at an index and said, download number 3, and it magically appeared on your computer. And the Archie people then created Veronica, which included Gopher servers in their index. And at the same time, the World Wide Web sort of came into being, but it was nothing special because, one, we were sort of still caught in this character-oriented stream because slow speeds were still de rigueur. So we sort of plugged along, and Waze sort of showed Google the way, Gopher showed Yahoo the way, emails got tied together. You couldn't do emails with pictures until mid-1990s. And so what you had is Gopher, really. And Gopher, the left-hand side of the screen is a...
One more minute, Ed.
Okay. Left-hand side of the screen is a Gopher gateway. There are Gopher servers still out there. You would normally have said push 6 to get the current weather and gotten this output of it, but there aren't many Gopher servers, so they've built a web interface to it. Now, if you look at this, it's not really great, but if you look at the first World Wide Web page, it wasn't very great either. So you had this battle where Gopher servers were really easy to put up text on, but that's all they would offer was text. The World Wide Web, you had to basically rewrite all of your documents by hand because there were no editors left yet. And so it was really onerous to put up a World Wide Web page. But in the end, the World Wide Web wins the war because higher speed and graphics take over. And that's about it.
Ed, thank you very much indeed for covering the remarkably primitive ways that we managed to access resources and the level of invention there was to make that actually work. Thank you. We move on to our next speakers. We have 2 speakers going to cover this topic. It's Milo Medin and Tom Stone. Milo worked at NASA Ames, where he architected and managed the global NASA science internet, including connections to wild places like the Antarctic. He was co-founder and chief technology of Excite at Home, and later joined Google as vice president of access services. Tom Stone was also at NASA. He was the Antarctic project leader, I believe. And he's now one of the people behind the communications network for future Mars missions, incorporating internet protocols. Over to you guys.
Thank you, Dennis. It's great to see everybody. I just looked at the list of attendees. It's great to have so many old friends together and some new friends. I thought it would be great to have Tom on this presentation because he was the guy who actually traveled down and actually made all the nuts and bolts of the system work. Just for context, let me give you let's go back to the year 1991. back then, we had networks like the NSFnet, which were working with regional networks to provide general purpose connectivity. But you also had agency mission networks. And at NASA, our network, our component of the internet was called the NASA Science Internet. And our job was not generally to provide connectivity broadly, but to serve specific NASA mission needs. And we, like our friends in the Department of Energy at the ESNet and the Department of Defense with the MILNet, all were working on solving specific mission requirements. That didn't mean that we didn't think about connectivity writ large. We had connectivity into Australia and several other countries that we tried to generate internet topology by not having to go in and run connections all the way to specific researchers in Australia, but we worked with the country's academic organizations to build local infrastructure, so we didn't have to manage all that. But we would provide the connectivity back to the US, and over time, the costs of the upgrades would get reapportioned. And so we tried to be creative in solving our needs for our users. Let me present a copy of, this is what the NASA network looked like back in '91. I think you should all see that. And back in those days, my boss at NASA headquarters, Tony Villasenor, was talking to the NSF folks in the polar programs, because NASA had scientists down that were working in the Antarctic about putting connectivity in there. And we worked with got a proposal for a company guy, Tom. It was IDB, right? I forget what the name was.
The STARS was first, and then they were bought by
yes, and
MCI.
And we got a good deal on a used Intelsat spacecraft in geostationary orbit that was sort of low on station keeping fuel, and they moved it into position so that we could construct a link from Antarctica from the McMurdo research station, U.S. station in the Antarctic, to California. And that was problematic because, as you know, satellites in geostationary orbit, the more closer to the poles you get, the closer to the horizon that antenna is seeing. This satellite was in an inclined orbit, couldn't maintain its position. So for part of the day, it was high enough that we could hit it with a ground station at Black Island, which I think was like 40 clicks north, and then of McMurdo, and then going over a microwave relay across the ice cap to McMurdo base. Later, this was replaced with a production satellite, Intel satellite, and Intelsat satellite that was created service available 24/7. And then we also put a link into South Pole Station by being able to hit a satellite that would pass over the pole and link McMurdo to South Pole Station. That was later replaced as well. Tom, you want to talk about the fun you had in getting a Earth station installed over at McMurdo?
Okay. We can get on here. I think you need to stop sharing. Can everybody hear me?
Yes, indeed, Tom. Milo, you need to stop sharing so that Tom can share.
I will do that.
Okay.
Thank you.
A long time ago, in an agency that was actually functional, I worked for Milo in a group called NSI, NASA Science Internet. And we were pushing an obscure set of protocols called IP against the tide of acceptable stacks like SNA, DECnet, and ISO, which of course are still wonderful now. Actually, NSI was more of a cult than a project, and Milo was the guru and seer. We undertook to support NSF with building a communication infrastructure from a MURTA station and later at South Pole Station, and that wore my South Pole t-shirt right now, or sweatshirt. I was the project engineer and coordinator of the Antarctic product, but I was also supported by a small group at Ames who were just completely competent. So I had no problems with anything. If I needed anything, I would just get back and it would be provided. Except I needed gloves and they didn't come very fast. The first goal was a proof of concept, and we contracted with IDB and procured, with my help, a 7.2 Vertex C-band dish to access Intelsat 503, which was inclined orbit. To save fuel, they let it drift north and south. So that's what incline means. The first year, what we did was put together a rather strange topology of stuff that had never been done before. We had a video codecs, which had never been tested on a satellite before. We had didn't know how much data we could get over the internet with the long lead time and other things. And so we decided that, oh, since this is completely experimental and the only one who thought it would work was me and Milo, we told ABC News that we would be able to have them do a live broadcast from the ice, which was the first broadcast out. We put this stuff all together. The truck came into Ames and to our ground station. We ran cables and it actually worked on the first try. And the next thing we did was we had scientists down there who did telepresence, including diving into McMurdo Sound. And we, at the Air and Space Museum, we had a little booth and people could come up and drive the little vehicle under the ice. We had a 6-year-old who was really good at it. And we had a bunch of NASA bigwigs who couldn't do anything. So that year, we had to stow the dish, and the next year they built a radome around it, which is a building. So that would protect it from the elements. And Black Island is called Black Island because there's no ice and the reason or snow. And the reason is that the winds are like 100 miles an hour continuously, keeping everything away. It was a wonderful place. No mosquitoes. That was the best thing. But we then started to get service at 500 kilobits. And the next year, we decided to do South Pole, and that was a whole other complete structure. We got an old Merisat, which was an Inmarsat, ancient satellite. I had an Earth station, which I had to modify. Let's see if I can get a picture close up here. That was what I took down, and I took the antenna off and ran it to the top of the dome at the South Pole, and went up there with some people. We all took turns standing up, so for a short time I was the lowest man on Earth. Then at the same time, we upgraded the link to for 64 kilobits, and then we did a whole T1. And we had problems with that. There was a problem with the modem.
1 minute, Tom. 1 minute.
Are we running out of time?
Yeah, afraid so.
1 minute.
Okay. So anyway, we actually got this all working, and we got South Pole working very well. I came back the next year and we did a live from with PBS, which was a group of TV, live TV from both McMurdo and from South Pole. It was the first broadcast from South Pole, and we did that. NSF decided they didn't like the South Pole connection we had. It was too expensive for them. So they took it down, but then the next year they contracted to buy the whole satellite and run a T1 over it rather than off 56. So, but at least it wasn't done by NASA. They didn't like NASA having control. They actually put in another dish by the Navy so they could run our Intelsat on that. So, but anyway, that's the story. We had Milo was the genius behind all of it, and I was the guy with the screwdriver. So, thank you.
Thanks, everyone.
Thank you, guys. Fascinating to hear the Heath Robinson type of connections that worked, and lovely to think of the video and broadcast from the South Pole. Well done. Okay, thank you for that. Let's move on. Our next speaker is Yvonne Marie Andres. 2017, she was inducted into the Internet Hall of Fame. She's an e-learning visionary, a founder of Free Educational Mail, or Fred Mail, Global SchoolNet and Global Schoolhouse, and has designed innovative programs to demonstrate the power of online collaboration to engage young people in activities, to improve their academic performance, and also to help local communities while connecting them globally. One of the 25 most influential people worldwide in educational technology. She received the International Making a Difference Award for advancing the status of women and children. Yvonne, it's over to you to talk to us about education on the internet.
Hi, everyone, and global greetings from Global SchoolNet. And I'm very excited to share my personal story with you of getting involved in the internet in the early days, and specifically as an educator. I'm a career educator, taught everything from elementary school through university. But my story today really is going to focus on what I call collaborative learning. And even though the internet was used for other things, a lot of providing a lot of resources and computer assisted instruction, that kind of thing, what I've always focused on is creating an audience for my students. And that comes from the idea of constructivist learning, which is a little bit of an education jargon, but it means people will learn best when they're involved in the construction of their own knowledge, where they create some sort of evidence or artifacts of what they've learned, where they share it with an audience, and where they get feedback from that audience. So everything that we've done in the last 30, 35 years using internet connected learning, I call it, and in the early days, pre-internet or through email, and then through the web and through video conferencing, has really focused on that. So hopefully you're seeing my slides. And the first one there is a cover of a magazine that doesn't exist anymore. It's called Teaching and Computers. And that's a picture of me and my junior high school students in Oceanside, California, which is adjacent to Camp Pendleton. And at the time, I was teaching these very low achieving students in sort of a very rough neighborhood. And a lot of their parents were either in gangs or they were incarcerated, and they just didn't have a real appreciation for education. So I was looking for something that would get them really excited. And the thing that I discovered was giving them an audience. So we transitioned from the postal pen pals to email when that was available. And we had my students who had parents that were constantly being deployed because they were in the military and they were going to different places. And we connected them with other students in similar towns around the world, around the country first and around the world, to share their experiences. And it had such a transformative effect on my students that sort of set my career path. So let me go on to the next one here. And there we go. All right, so the guy in the corner flipping the floppy disk, his name is Al Rogers. And I connected with Al back in the early 80s. And we together had this vision of connecting young people to do different kinds of writing projects and science projects. But nothing existed for education. So kudos to Al. He went into the what we call the pirate community, and he found a bulletin board system, which at the time was called PMS. Probably not a good name anymore for a bulletin board system. But anyway, he convinced the teenager that had written it to donate it to education. And Al rewrote it, and he wrote, we called that Fred Mail, Free Educational Electronic Mail. It ran on Apple IIe's and Apple IIgs computers. It was using floppy disk. It was text-based, email, news groups. We set up a bunch of special interest news groups. And as Ed had mentioned earlier, it was based on this concept of store and forward. So none of the schools had extra phone lines for modems and things like that. So we had to tap into the only phone lines at the school, which were either in the nurse's office or the principal's office. And of course, we couldn't do that during the day. So what we did was we set it up so that it would connect during the middle of the night. So students would write their stories, their letters, their science projects, whatever we were doing. They would put it into the system, the Fred Mail system, and the system was smart enough to know to send these writings in the middle of the night. So this is a map of what the Fred Mail network looked like in 1988, not the full map, but just to give you an idea of how it works. So we had connections. We had about 300 nodes or hubs, and these were located at school districts, at universities, across 5 continents, and at several supercomputer centers. So the way it would work is there would be these, the hubs would have a special software that would gather, it's kind of like a post office, would gather all the mail and then send it out to the different locations. And all of these little acronyms here stand for different locations. And what you see here, and right in the middle, that's San Diego State University. On the bottom, you see San Leandro. On the top, you see Oceanside. That's where I was located. That's the school, where the school was that I was located. There was the San Diego County Office of Education. To the right, you see Bladen. That was a bunch of different locations in North Carolina. And then some of these had overseas connections. So they went to places like Brazil and Ireland, Australia, Canada, New Guinea, and places like that. So go to the next slide. So in 1988, we wrote a book called Telesensations, and it was self-published, and it was in a binder because things were changing so quickly that there wasn't time to create an actual printed book. So I looked through this binder preparing for this talk, and the first half was all about using different tools like Gopher and Archie and FTP and 300 baud modems and how to connect. And the second half was, what do you actually do with it? So if you're going to go through all that trouble and all that expense to have that equipment and learn how to use that equipment, and keep in mind, there were no training classes. Almost all of this was, self-taught, through different people that were evangelists or passionate about the topic. In the upper left-hand corner, you see a picture of Captain Internet, which shout out to Susan Estrada and SurfNet. Susan somehow found out about what we were doing and really embraced the whole idea of K-12 education on the internet. And that summer, I wrote a book for with Susan called Surf and Safari, CERF and Safari. I couldn't find the picture of it, but again, it was not only chronicling what tools there were, but how to use those tools to accomplish something that would improve academic achievement. Okay, let's jump forward to 1992. 1992, I got this most amazing phone call, the phone call that everybody wants to get, and it was from the National Science Foundation, and they said, if we gave you a lot of money, would you consider demonstrating how you can use live video in a classroom? And I thought, okay, this sounds pretty interesting. So they connected us with Cornell University, and shout out to some of the people I worked with back then, Dick Cogger and Tim Dorsey and Scott Brim and a few others. And at that point, CUC-Me was point to point. It was black and white. It was very herky-jerky. You did the audio separately, but you could actually see the person on the other line. And even though we had been doing this online learning, this collaborative learning for almost 10 years prior, nobody got it like they did when they saw these students sitting in front of a computer, like in the bottom right-hand corner there, and actually communicating with other students. In 1992, we had the first live internet TV show. What you're looking at is World News Now in New York. And there was somebody there that said, this internet thing sounds kind of interesting, and wonder if we could demonstrate how it works. So we connected students in Oceanside, students in Australia, because this is the middle of the night for California. And we did the live broadcast, and that's actually, there's a video of that online, so that's kind of fun to watch as people talk about whether this whole internet TV, live internet streaming thing might catch on. So jump forward to the web. So in 1994, right after CUC-Me, we created our first website, and we began to populate it with all kinds of collaborative projects. One of the things that we specialized in was online expeditions. So we were able to connect young people with real people doing extraordinary things, climbing Mount Everest, sailing solo or rowing solo across the ocean. All these really wonderful projects. There was one adventure where they were riding camels through the desert and through Australia, and the students were able to help guide their journeys, ask them questions, environmental questions. Again, all of it was based on learning, sharing, creating some sort of evidence of what they learned, discussing it, and then of course assessing their knowledge. Our biggest project, our still running project, is something called International Cyber Fair. And this was developed in 1995 with help from Cisco Systems and MCI and some other companies back then. And the idea was to have young people, connect young people with their community. And so we decided to create a virtual online World's Fair. And students would create these digital exhibits about their local leaders, their local history, environmental issues, music, art, sports, and then publish them online. But they would also tell the backstory, because often you see the final result, but you don't know how people got there. So it was very important to us that they say what technologies they used, what challenges they had, how did they have to overcome any obstacles, how it supported coursework, and so on.
1 minute, Yvonne.
Okay, so if you want to do a collaborative project, how do you do it? You need to find a partner. So we created something called the Internet Projects Registry, and people could choose the curriculum they wanted. They can choose the kind of technology or the kind of collaboration, whether they wanted to do information exchange, database creation, live expedition, and so on. Current trends. All right, what are we doing now? Right now, I'm working on a project called Wi-Fi Education, and it's a collaborative analysis of predicting and managing wildfires using artificial intelligence. This is a huge grant, not that we got, that UCSD got, but we're doing a very tiny portion of it, which is the education portion, which is helping the public understand why this is an important topic. And current trends are to use these visualization simulation tools, connect to your careers, and connect them to experts. And finally, we hope you'll connect with us because I would love to collaborate with all of you. Thank you all.
Yvonne,
I'm going to stop sharing right now.
Yvonne, thank you so very much. Fascinating and well done. A lot of information in a short period of time. Thank you so much. We move on to our last talk, which is given by Larry Smarr. Professor Larry Smarr was a computational astrophysicist, with which I have great empathy. I was once briefly an astrophysicist. He was back in the 1970s and 1980s. He served as the founding director and served for 15 years at the National Center for Supercomputer Applications in Illinois, the NCSA, famous for being a supercomputer center and for a browser and so on. Larry will talk about that. During that period, they developed PC Mac software to enable remote users to interact with supercomputers over the then evolving internet. After 20 years, most recently as the CALET 2 founding director, he's currently a UC San Diego Distinguished Professor Emeritus. Larry, the floor is yours.
Thanks so much, Dennis. Can you see the slides okay?
Yep.
Good. So Dennis wanted me to talk about using remote supercomputers over the emerging internet from workstations or PCs. I just wanted to point out that actually when von Neumann was developing the original digital computer, the idea was that it would produce so much data, and of course this is something going at hundreds of flops or something, that you needed to move the output into an oscilloscope and then watch the oscilloscope. And so this whole idea of what we call client server is there from the beginning of the architecture. I did my early work in computational astrophysics at Lawrence Livermore Lab with Jim Wilson, and then later at the Max Planck Institute with Mike Norman and Karl-Heinz Winkler. And what you see on the left is the actually just a little bit beyond tectronics that Ed was talking about, which is the first collision of two black holes and the gravitational waves they generate, which indicated that started the 40-something year march to where we are seeing all this today. But the point is that while we were using supercomputers, all of it was coming through visualization, and that was done on workstations. Now, in 1981, there was a seminal report that Rich Isaacson at the NSF pulled together on what would computational physics require in the way of infrastructure. And that included Ken Wilson and Steve Orzog and myself on a panel run by Bill Press. All three of those later became NSF Supercomputer Center directors only 4 years later. And what this report is very prophetic about is it says, yeah, there's got to be central supercomputers, but there's also got to be these local nodes, we called them. And in those days, we were mainly thinking about workstations because the scientist does their work on the workstation. The workstation, the local node, then uses the remote supercomputer, and it has a lot of graphics on the local node, a lot of I/O. And so it was as important to develop the local node as it was to develop the principal node. And this was 1981. Well, what I find, even looking back today, just incredibly difficult to believe, is that in just 3 years, we saw the IBM PC in 81, the Macintosh and the Super Bowl commercial in 84 introduced, and this enormously created many orders of magnitude more local nodes that were much more capable. And so that was just at the time that I was writing up this supercomputer famine in American universities, this underground Samizdat passed around on mimeograph forms and so forth. led to the so-called black proposal, which was an unsolicited proposal to an NSF that didn't have a supercomputer program in '83. And it was all about the different end users, the different application areas that could use supercomputing if there was an academic supercomputer center available. Long story short, the NSF had a lot of blue ribbon panelists, the Lax report, Barton Curtis report, then decided to create an Office of Advanced Scientific Computing and have a national competition. 2 of the 5 winners, Sid Karen at San Diego Supercomputer Center and myself, were from the national labs, the DOE labs. And so this whole notion of mass store, of remote MFE net, for instance, a network that there was a local node using the supercomputer, this was baked into both NCSA and SDSC from the decades, actually, of development in DOE prior to that. Now, what's amazing is, of course, we all say that supercomputer centers and the Office of Advanced Scientific Computing came out in '85. But that very year in June, there was a congressional meeting in which to discuss the emergence of supercomputing. This is on federal supercomputing programs and policies. And yet, when I went back in congressional record and pull out the testimony, you have Al Gore, who had just become a senator, and he was invited to this meeting as a former congressman. And he's talking about a national initiative to build interstate information superhighways with fiber optics connecting the major computational centers in the country, which there wasn't any at that point. And I'm talking about at the University of Illinois, we're actually talking about getting to billions of bits per second. Now, this is at a time where the NSF net in June doesn't exist. At a very important meeting in Boulder that Dennis Jennings had with the new supercomputer centers from Princeton to Pittsburgh to Illinois to NCAR, the existing atmospherics research one, to San Diego, we had a meeting out on a balcony and we actually sketched out on a napkin, and this is from Jim Bottom, who was there, who was working in OAS in the Office of Advanced Scientific Computing at the time. This was in September. So in June, we're having congressional testimonies talking about billions of bits per second on a future optical fiber internet. And in September, this is on a napkin, which Dennis, as the first program officer within the Office of Advanced Scientific Computing in charge of networking, then created the NSF net with a 56 kilobit backbone. At a time we're talking about billions of bits per second. So this is all compressed into just a few months difference in '85. Well, once we had the supercomputers, this is the Cray 2 processor XMP at NCSA. This is Professor John Kogut, he actually used so much computer time on the new supercomputer, which is for the whole country. He used one of the 2 processors. The other one was for everybody else. But here is a picture of him actually using it on a Macintosh. The Macintosh is running NCSA Telnet, which is then using the remote supercomputer. And Telnet, of course, as Ed was saying, that existed on Unix computers, but what NCSA Telnet software did, we developed it at NCSA, allowed us to take what you could do on Unix in terms of FTP and remote login, and brought it to the Mac and to the PC. And so NCSA Telnet allowed you to go from the data generator in the supercomputer to the portal to the human over, and there you see on the floor the network connecting them that did the data transmission. So we had this whole idea of hide the Cray. This is from about '86, where here's the Cray, here's a VAX front end, remote workstations, here's the mass store. And this literally would show up on the Macintosh, and you could click on any one of these, and you would essentially remote log on, and it'd be running on that computer. And this is from an article in '88 that I wrote, and we're saying once the supercomputer, which at that time had the Livermore Cray time sharing system, Once that has a Unix operating system, which was considered very radical, the idea that a supercomputer could run Unix, and a network with a uniform protocol like TCP/IP, then we would have the final unification of the workstation and the supercomputer. But it was tough in those days, as Dennis points out. You didn't just have the NSF-net, you had ARPANET, BitNet, Telnet, as Ed was talking about, direct dial. So the real advantage of having this PC software or a Mac software was it sort of let you, each individual user had to work through what the size of their files were and how much network they had, and so it was a very manual approach. So we continued to develop this software with NCSA Image that allowed you to use a Macintosh as what was previously only computer graphics could be done on a couple $100,000 workstation. Now you could do it on a Macintosh. And then we wanted to be able to make it so you could collaborate and share your desktop, just as we're doing now in Zoom. Well, this was 91. Was the first version of all this where you could do that. And that was called NCSA Collage that everybody's forgotten. We did, but we wanted to have a module that will bring in hyperdocuments. And one of our undergraduates found out the World Wide Web that Tim Berners-Lee had done in about 1990. And so we started up a group called Mosaic to create a module for collage. And this is my last slide. This is an actual data from the national backbone. And this is in powers of 10, the amount of traffic across it. And here you are in November of 92, where the World Wide Web is in blue. Here's the waste that Ed talked about in green, and here's Gopher he talked about in red. And then this is from November of 92 to November of 93 on into 94. And here's when Mosaic became available. And you can see on a log scale that there was this exponential growth as soon as Mosaic, both the browser and server, became available, crossing ways, exponentially crossing Gopher, and essentially being 10,000 times the traffic in just a year and a half from the introduction of Mosaic. And that led to the explosion of the web.
Thank you, Larry. Fantastic. Thank you for doing that. We have one interesting question that's come on the Q&A. It's a number of comments. The question from Mike Nelson is, what if Tim Berners-Lee had patented or trademarked or whatever the World Wide Web technologies? Would the internet community have used it? Would the internet community have done something else? And it's an interesting question, but it doesn't take account of the environment at the time, even up to the early 90s, 1991 and so on. The environment at the time was, we were building, and this included CERN, where Tim Berners-Lee was, we were building networking for research, for academia, for a community. And so the concept of patenting something didn't enter Tim Berners-Lee's head. It did enter the heads of the CERN people, who are very interested in making money out of the software activities. But the culture was that we were building a community-wide network. And that drove the NSF-net, that drove Waze and Gopher, that drove the web. And so, although it's an interesting question, it wouldn't have arisen, in my view.
Dennis?
Yes.
I had this funny thing happen with this very question. Long after the fact, one of these people that buys up technologies and then tries to apply a patent to them called me up and wanted me to be an expert witness about the World Wide Web being the first merging of photographs into a text document over the net. And I said, well, I have this problem because the Plato system on the U of I campus, which was a completely different technology. It had this very boxy monitor, but it had a microfiche. You could put a microfiche in it and your lesson could say, put up slide 3 on your terminal, and it would back project it onto this plasma terminal. I said, but this has been around for 20 years and I never heard from them again.
Well, thank you for that, Ed. We've actually run over time. So I do apologize for that, but I personally found the talk so interesting that I let them run. And I hope the audience out there also found the talks interesting as I bring this session to a close. Speakers, thank you all very much indeed. Ed, Larry, Tom, Milo, Yvonne, thank you for your time. Thank you for the effort. And let's hope that the interest considers and we'll have a 4th session one of these days. Thanks and goodbye.